we can look at how linear systems can interact with each other. So let's say we have a line, and how many ways can another line interact with the given line? So we know what we've been looking at throughout this unit is we could have another line, let's say, cross it, and we could end up with like a point of intersection, POI. You get one point of intersection. But we also could end up with maybe another line that runs exactly alongside of it. And in this case, these would be parallel lines, which would give us 0 points of intersections. And then the third way that we can have a line interact with another line is if it actually just falls, maybe using that wasn't a good idea. Let me use green. If the line falls right on top of the other line. And in that case, we say that they are coincident lines, which means that they are the exact same line. And then there are infinite number of solutions because they're the same line. So they would have the same point of intersection here and here and here and here and here and all along that line. So these are the 3 different ways that we can see lines interact with each other. Now, how do you know when you have parallel lines? So that's kind of a good thing to see. And I want you to show you when you have parallel lines. So let's say we have these 2 systems of equations. Okay, so let's solve this by elimination. So let's see if I decided to eliminate my x's. Let's say I'm going to multiply my top line by 2 so that my 4's in front of my x's would be the same. So I would have 4x plus 6y equals 14, and 4x plus 6y equals 10. And then I'm going to subtract. Okay. So 4x minus 4x is 0, so that's gone. And 6y minus 6y is 0, so those are gone. And then I have 14 minus 10, which is 4. So I end up with 0 equals 4, which is a false statement. Okay, and that must mean that there is no 0 points of intersection. Okay, 0 points of intersection. Now, it could be written maybe this way too. Okay, and if it's this way, it's even easier to see because let's examine our slopes. So this has a slope of 3. This has a slope of 3. So these have the same slopes. And we know whenever we have the same slopes that we're going to end up with either parallel lines or the exact same line. Now we know that they're not the exact same line because look at our b values. Our b values are different. So same slopes, but different b values will give us parallel lines. Okay. Now, these are the same lines. Another word for same is called coincident. So if you happen to see the word coincident, that means same lines. And so same thing, if I was going to do elimination on this, I would multiply my top by 3. So I would get these 9s that are the same. And I would have 9x plus 12y equals 27. And then 9x plus 12y equals 27. And look at this, we ended up with the exact same line. So when that happens, everything's going to cancel. We get 0, we get 0, we get 0. So 0 equals 0, which is a true statement. Like 0 does equal 0, but this is where we're going to have infinite points of intersections because it's the exact same line. And again, if you were going to examine, let's say, a couple of equations, notice that my slope here is 1/2, and my slope down here is 3/6, but 1/2 and 3/6 are exactly the same. And here I have a y value of 2, or sorry, y-intercept of 2. And down here I have a y-intercept of 4 over 2, which is also equal to 2. So we can see that these are the same slope, same y-intercept. And when that happens, we have the same line. So same slope and same y-intercept equals same line, which will give us infinite points of intersections. Okay, so just a little chart here to help you keep it all organized. One point of intersection will happen if your slopes are different. It does not even matter about your y-intercept. If you have slopes that are different, then you're going to end up with 1 point of intersection. You'll have 0 points of intersection. This is parallel lines. 0 points of intersection is if your slopes are the same, but your y-intercepts are different. And then these are the same lines. If you notice, your slopes are the same and your y-intercepts the same, the exact same line. There's an infinite number of points of intersection. So just a little chart to keep it all organized in your brain for you.